Hey, welcome to this video on force vectors. Let's look at the question, and it says that there's a mass of 5 kilograms that is suspended, and there is a length of string provided on each side. Also, the distance between those fixed points, strings that are attached to fixed points, is provided as well. So fixed point on each side, the mass is pulling the string down. So there is a tension in the direction of each string, T1 and T2. That 5 kilogram mass is pulling down, and the force Q in that direction is defined as the product 5 kilogram times 9.8 newtons. So we'll use this numerical value for calculating the tension force in the direction of each string. So this is why we have 5 times 9.8 is equal to 49. So we drew a diagram that represents the situation provided in the question. Sometimes or oftentimes there's no diagram included in the question, so you have to create your own. So force Q is balanced by force F, which is directly opposite to Q. So the magnitude of F and force Q are the same. We will be using two diagrams here. The diagram that represents the strings will be useful for us to find the angles, because 3 sides are given, so we will be going after angle alpha and angle beta. The force diagram here on the right side of the screen, which defines the following: that force F is the total sum of tension 1 vector plus tension 2. And please note that the tension 1 and tension 2 force are in the direction of those strings provided. So knowing the value of angle alpha and beta is very, very useful here. So now, please note that 32 squared and 24 squared is the same as 40 squared. If you did see that from the beginning, then you would make note that the given triangle is a right angle triangle with 90 degrees here. But we didn't have to see that necessarily. So if that's the case, then alpha and beta adding to 90 degrees as well. But let's say we haven't noticed that, and we still have to solve the problem. So why don't we find angle alpha and beta first using the cosine law? Okay, so using the cosine law, we can quickly figure out the value of angle alpha. So there you go. So once we have one angle and 3 sides provided, we can use a sine law to find the value of angle beta. So given the ratio, beta is 53.1262 degrees approximately. So now, since you recall the force diagram from the previous page, we needed to find 90, the complementary angle, and 90 minus alpha and 90 minus beta. So this is why we have the following values. And please note on this diagram right here, force F is the resultant force of tension 1 and tension 2. We have 2 angles provided, so the third angle actually is 90. When you add 90 minus alpha and 90 minus beta, you'll get 90 degrees. So now, since we were actually certain that this is a 90-degree triangle, we can use sine or cosine ratio to find tension T1 or tension T2. So let's go ahead and do it. So using the cosine ratio for force T1, we get the result for that ratio, and T1, please note this is in the direction of the 32 centimeters. Similarly, for setting up for the tension T2 in the direction of 24 centimeters, we set up sine ratio, and after calculating the ratio, we get 39 and 0.1331 newtons. So this is approximately the value for both tensions and the corresponding directions. I hope this was a very useful video for you and you understood how we solved the problem, and see you next time.